Chapter 10, number 46. Suppose a bicycle wheel is rotated about an axis through its rim and parallel to its axle. Is its moment of inertia about this axis greater than, less than, or equal to its moment of inertia about its axle? And then choose the best explanation. So we have a bike wheel, and the axle is, of course, a thing, if you sort of think of it orthographically, is sort of coming out like this. And usually we rotate it about that point. They are saying, let's do it instead about this point. So the wheel will start off like this, and then it'll be like this, and then it'll be like this, and then like this, and then like this, and so on. Of course, same radius each time. Our key bit is going to come back to saying that the moment of inertia of something is something like some number times the mass times the distance squared, where the number comes out from the geometry and some usually grungy calculus, but is always that the further out a piece of mass is, the more dramatically it contributes to I. So if we look at our two situations, if we go about the center of the wheel, in the red case, then on average, mass is at one radius, which is pretty close. And that will give us sort of our standard. But in the second case, where we have, we're going from this point, some of the mass is at 2r. And that means it's going to contribute, I is going to be proportional to 4r squared. It's going to be 4 times as effective. So, of course, some of the mass is at very low r, but on average, half the mass is further away in this case than it was in the simple case. So maybe to redraw these two cases, we have about the center, and all of the mass is a distance r. And then we have about this axis through the rim, and if we think about it, half of the mass is further than r, but half of it is less than r, and you might think that means they all counteract, but they don't, because the r squared nature means that the top bit being further away is more important than the lower bit being closer. So we should end up with the moment of inertia of the new axis is greater than the traditional axle. And if we say which of these are we going to say, it would have to be 3, because the other two are not in any way true. Mass is on average further from the axis when the wheel is rotated about its rim.